Hi everyone, my name is Joshua Gis, and I'm a senior electrical engineer here at Morgan State University.
Hi everyone, my name is Dennis Ndati. I'm an engineering teacher at National Academy Foundations in Baltimore City Public Schools.
Alright, and this is our presentation on traffic light management through visible light communication for the REU Smart City program. Our project goals were to develop a traffic light management system using Arduino Nano that would display traffic signal time, as well as design and research future applications of a traffic light management system.
The other goal for me as a teacher was to develop lesson plans and activities that are related to the project that I'm doing here. I also have a long-term goal to develop a partnership with Morgan State University and a REU program with National Academy Foundations. I'll talk about this later on in our presentations. So just the introduction of what visible light communication is. So visible light communication is a wireless communication technology which utilizes the visible light source as a signal transmitter and appropriate signal receiver component. And the receiving component could be any electronic gadget, for example, your phone, computer, and stuff like that. The visible light has a bandwidth of about 400 terahertz, which is about 1,000 times greater than the radio wave, having about only 300 gigahertz. The advantage of using visible light communication is that it uses light as a communication medium, which is much faster than the radio. As you can see, the radio only has a bandwidth of 300 gigahertz, while the visible light has 400 terahertz. The visible light uses light emitting diodes operating at a variety of frequencies, and it's provide low cost because we're using LEDs, which are very cheap. It provides low cost, energy efficient wireless communication to obtain higher data rates. Visible light also does not require any additional infrastructure and is very secure, because if you compare the visible light with the radio wave, you must have a channels which can sometimes be very insecure. So there are multiple applications of visible lights, such as data streaming, positioning, wireless communications within a defined area. In this project here, we are going to apply two of them. Data streaming from the emitter side. We're going to transmit that data wirelessly to the receiving side.
Alright, so here's an overview of how we started off with our research methods, through our department and individual analysis to IoT Smart City concept and future applications. Thus, we started focusing on our Arduino platform and finally researching Manchester encoding for our modulation scheme. So firstly, we started here at Morgan State University using the CBIS building, the Center for Built Environment and Infrastructure Studies. Here is where we first met with Dr. Jehani and Dr. Celeste, who helped me get a bunch of resources that helped me come up with the idea of what VLC is based on and how this could appeal to everyday drivers by putting myself in a driving simulator to see in what format the driver will be most comfortable with. The challenges were initially the limited resources on campus, since we had to find our own resources before we could use any that were available to us, as well as creating future possibilities for the VLC system. Finally, we had to establish an IoT and security application for future research and implementation in a smart city.
So we are going to apply the concept of the visible light with Arduino platform, particularly Arduino Nano, to manage our traffic system. We did a lot of research on VCL and how it is used with the traffic light. There are several identical models out there, but none of them had the specifications that we were required to have in our system. For example, we have to display time. None of these models that we saw had the time being displayed. The other thing is, for our system, we have to have 3 different traffic lights between 3 different LEDs, and each one of them have to have its time being displayed. Again, this is something that we not find in any of our readings that we did.
Okay, so moving on to the Arduino platform, we had to research and understand what the Arduino IDE was, as well as the libraries associated with it, because many of our sample codes were already made with libraries built into them, such as Timer 1 and Receiver Type H header, which helped us implement most of our code, as well as Manchester encoding. The difficult challenge going forward was understanding the connection between Arduino Nano and the already existing Manchester encoding, because Manchester, we use it as a modulation scheme, which is a form of digital coding that transmits data as bits that are either high or low for communication. Many of the sample codes we found were already supported by our VLC system, but since we didn't understand how Manchester encoding worked, that gave us difficulty when we wanted to add in our own code for the traffic light commands and controls.
So here's a look at how our conceptual diagram for our prototype will look. So our traffic management prototype has the receiver component. So we have the emitter component and the receiving component. And the data that's being emitted from the emitter is transmitted wirelessly to the receiving component. So we're going to have a look at each of these components separately.
Okay, for the emitter components, we use Arduino Nano, a green, yellow, and red LED, as well as an infrared LED, jumper wires, and a 330 ohm resistor. So here you can see our emitter circuit. First, we loaded our Arduino sketch, which was made using Manchester encoding onto an Arduino Nano. Thus, this broke down the binary and hexadecimal code into an emitter message using the LEDs, which was then picked up by the receiver. This message was sent using on-off key modulation to actually control when the message will be displayed using each emitter. For our testbed setup, here we have an IR LED in the upper left-hand corner, which we use for our first example to test to see if we could get it to go on and off in a controlled sequence. Then moving forward, we tried using 3 separate LEDs to replicate a traffic light. Here's a video sample of what we did.
So the green light for 5 seconds, yellow.
As you can see, each of the traffic lights are alternating in a time sequence based on the Arduino sketch we had to write for the first sample.
Yellow.
So for the receiving components, we also used Arduino Nano. We used the IR receiver, jumper wires, and 120 ohm resistors. So we have the IR receiver that receives the signals coming from the emitter. Those signals get converted back into binary data or hexadecimal based on the Arduino sketch that we had using Arduino encoder. When those messages get converted, then they get sent to the LCD display. And in our case here, we're going to display the time that is left for each light to turn, either green, yellow, or red. So this is the setup of the testbed that we had. As you can see, we just had a single IR receiver connected to Arduino Nano, and then we also had the LCD display. So the initial results that we had when we did the first test was we just connected an ordinary LED and our IR receiver, and we were able to see some data coming in. And initially we thought we were having the right data because we are getting the binary numbers, the zeros and ones. But when we talked to Dr. Nyarko, he told us that those were not actually the correct result that we were supposed to get, which was true, because when we went back and disconnected the receiver side, we were still able to get this data coming in. So I think the error that we're getting is because of the noise that were coming from the environment. Most likely we had a lot of other LED in the environment, and I think our receiver was just receiving random messages from the environment. So we went back and disconnected the whole test bed, and so instead of using the ordinary LED, we used the IR LED, and we had a new IR receiver and a new sketch that had Manchester encoding in it. And when we set the the testbed app, when we had the emitter side and the receiving side next to one another, we were able to receive data and display them on our LCD. So we are actually getting the exact data that we're emitting from the emitter side. So this is just a video that will show how the data was streaming in. So as you can see there, you can see
you just stop it and do it another one.
the data was actually coming in. We had this, oops, that was so quick. We had this loop that continued just running, displaying the data that was coming from the
you just stop it and do it another
emitter side.
Another one, this one.
And so, based on that,
Go again.
you just stop it and do it another one.
Another one, this one.
Let me try and get that.
yep.
Maybe a bit.
So hold on for a second, technical problem.
Alright, go again.
All right, so based on Josh is going to talk about the next step that we're going to take based on our result that we got from the prototype.
So now that the VOC has achieved communication between the emitter and receiver, we are now going to move forward and implement traffic light controls to replicate a real world scenario where a traffic light can be used to communicate using VOC between the light itself and the VOC valve will be built into a card to see how much time is left before the light changes. This will be the next stage of the project going forward once we enable this technology. Now, how to improve on the VOC for traffic light management. Using an amplifier circuit, we researched and discovered that it could actually help boost the receiver LED as well as the IR receiver. Also, using MOSFETs to drive the emitting LED to achieve higher emission power. Furthermore, if we were to improve the Manchester decoding to detect rising edge and falling edge instead of thresholding, that would greatly improve our chances. Furthermore, if we were to utilize our current Manchester encoding and change it from limiting the duty cycle to 50% and improved it on, we will notice the scheme will allow to also set the lighting brightness.
So here are the set of lesson plans and activities that I plan to do with my classes the next school year. So I teach engineering in high school, and the first activity that I have is for 10th graders. So I've realized how important it is for students to understand the concept of breadboard and how to connect component on breadboard. And therefore, this activity is going to involve students just use resistors and LEDs and connect them in parallel and series, and just use digital multimeter to test the current, voltage, and resistance. This will give them the skills that they need to use any of the platforms that we might use later on. For example, Arduino Uno, Arduino Nano, or Raspberry Pi, and so on. So the students will be able to understand how the breadboard is connected. The next activity is going to be for the 11th graders. So for the 11th graders, I intend for them to use the same platform that we used for their previous class. So these students have already taken a foundation class where they were able to use VEX platform and use Robot C to program different components. And so we are going to apply the same test bed, but instead of using the Cortex as the microprocessor, the students will be able to use either Arduino Uno or Arduino Nano, and then be able to write simple codes for those different input and output components that we have on the same VEX platform. And so this will give the students opportunity to learn how to a different platform and how to code. So as you can see here, this is just Robot C and Arduino IDE sketch next to one another, and you can see a lot of similarities between those two languages, and therefore I want these students just to strengthen their coding skills just by having another opportunity using a different platform. The next activity is for my seniors who will be taking their capstone project. So in this class, usually students pick a project and do that project for the whole year, and therefore Last year, I had students who actually used Arduino Uno as part of his projects. I know I was not able to help him much, but we were lucky to have a student from Johns Hopkins as a mentor who was able to work with him to complete his project. And therefore, I think I'll be more prepared to help my students this year in case they want to implement anything to do with Arduino Uno or Arduino Nano in their project. And therefore, what I intend to do is I already have some resources from Random Nerd, and they have several simple projects that students can take, and it explains step by step what they need to do. So I intend to pick a few projects from different models that they have, and students will work in groups in order to complete one project. And the whole idea here is this is actually not their main project, but it gives them opportunity to learn Arduino and its applications, and therefore in case they want to apply that in any of the projects that they're doing, then they'll be better equipped to use them. And I think I'll also be better equipped to help them through their projects if they so use any of the Arduino Nano or Uno. All right, so Josh will talk about our future work regarding this project that we've been doing.
Okay, so we have recognized that the VOC system offers a great opportunity to introduce new smart city initiatives such as a smart autonomous vehicle, as well as new forms of transportation or alternate forms. Going forward, me and Mr. Dennis would like to continue working with Dr. Nyarko for this research in regards to future applications such as IoT security and alternate applications.
And this brings me back to one of the goals that I had from the beginning. So I've already talked to Ms. Dr. Nyarko regarding a partnership, long-term partnership between Morgan State, RAU, RET program, and National Academy Foundations, and I'll be writing a request soon. So the intention here is to have this program continue to high school level, whereby we'll have Morgan State University that are in this program become mentors to high school students, where we can have a project that that is undertaken by students for the entire year, and Morgan State students can be incoming to my classroom maybe on a weekly basis or on a bi-weekly basis to work with students and monitor their progress. And then this becomes just part of the RAU program at a high school level. So thank you very much, and if you have any question, please feel free to ask.
Thank you, everyone. Again, if you have any questions, we'll be free for questions afterwards. All right, good. 17 minutes.